Okay, so in the middle section, rather than looking at the sums of the first n positive integers, we're going to be looking at the sums of the squares, which is the reason why I'm wanting them to talk about what they know about exponents at the beginning of the whole session. And just like with this situation, there's going to be two things. Like, why would we even bother looking for the pattern? What if you had 50 or 100 or 1,000 of these things? And also the side note about what if instead you had, instead of the 1 plus 4, what if you had 50 plus 200 and so on, but say a whole bunch more terms after that. So I don't know how many terms we want to have for them, but as I was saying earlier, I think we're only going to have just one example involving the manipulatives, given the number of blocks that are going to be involved. We've got plenty of that. So given how many blocks will be needed for this, etc., they can just have this first example. So, now we're back to talking about volume. This one we've got 1 plus 4, or 1 squared plus 2 squared, for a total volume of 5. But we also have a total of 6 copies of that. And just like with the sums of the first n integers, where they were able to put them together to make a rectangle, certain dimensions, I want to see if we can put these together as a rectangular prism, a box of certain dimensions, and see how its volume compares to that answer. You want to try it without looking at the cheat sheet?
Sure.
Okay.
Dang it. I'm doing the same thing.
Well, we know what they don't know, which is that it's going to have a dimensions of 2 by 3 by 5.
Good to know. Which is what's happening. That's cool. Oh, no. 2 by 3. That's so tragic.
It's what? Tragic?
Yes, indeed. Because that should be the last. Maybe I just rotated it wrong. 4. 3.
If nothing else, this can eat up some time.
Yeah, I can, that's for sure. Oh, I think I got it. Nice. It just doesn't go together because these are that little thing right there.
So you can't get them to
But I could do this.
stick together, but
Let me do this so you can do that. This might.
so it still looks the same after that rearrangement, but now you're trying to get them to lock?
Yeah, I'm trying to make them look like a cube or a rectangle, whatever. There you go.
Okay. So again, that 2 is coming from there being 2 terms.
Mm-hmm.
3 is 1 more than that. And 5 is double how many there were plus 1. And you're getting a volume there of 30, which is 6 times bigger because we have 6 copies of that.
Mm-hmm.
So unless we really want to even spend more time arranging something like this, which just a single one of them would have 14 blocks,
Be a lot.
like what we have there in that diagram,
Mm-hmm.
and then a total of 84 being used. Again, the important part is what if you had many more terms to add? What can we do as a second side note of if there's a common factor, and when you divide that out, that you would have a sum of squares.
Right.
And I don't know that you would have ever seen this. Mr. Can I say the full name, Mr. B, or should I just keep calling you Mr. MLC Director?
You can call me Mr. B, it's fine, like,
Come on out, Mr. B. I wonder if you've seen this.
what am I doing?
I want you to see something. Second differences. So it's not that we had an arithmetic sequence where we kept adding on 1 more, but if you go 2 layers deep with the sums of the squares, well, thinking about the sequence rather than the sum, that what's getting added on, if you go 2 layers deep, find the differences here, and then do the differences on the differences, that becomes constant. F of x equals x squared equals 2x.
It's like the discrete version of that.
Mm-hmm. And so that's the other thing is why all this stuff is being done overall, to make allusions to calculus applications, link it for that one student that was here last year to that activity that he experienced then, and also for all of them to financial applications, for example. The one we did with the geometric sequences connects to the formulas for amortizations, student loans, mortgages, annuities, etc.